Hello everyone, can you hear me? Good evening, all of you. Hope everybody are good. I think your preparation is going well. Most of the topics are covered, I think. Recently, we have done carbon and its compounds, chemistry. Now, because some of the students asked about magnetic effects of electric current, I am trying to clarify your doubts. So, let us discuss about magnetic effects of electric current today. So first we will be having what is a magnet. Hope everybody are having idea about magnet which attracts like iron like substances. It is a substance which attracts iron or iron like substances. Every magnet will be having two poles, north pole and south pole. You have idea about it, and like poles repel each other, unlike pole attract each other. This is what a figure of a magnetic pole in which it aligns itself. When you suspend a bar magnet, it aligns itself north to south, north and south direction it aligns. Then we have to know about what is a magnetic field. It is the area around the magnet in which magnetic force can be experienced. For example, when you bring a iron substance near the bar magnet, for some distance it will be attracted. When you are taking away from the magnet, what happens? After some distance it will not be attracted by the magnet. So till which area that iron is attracted by the magnet, that area in which magnetic force can be experienced will be called as a magnetic field. Then how do we identify a magnetic field? Where it is, from where to where it is closer, where it is weaker, and from which direction to which direction it will be. So to know that, we will be having one activity to identify the magnetic field lines. What is that activity? We take one compass and we start seeing we hold here and we start seeing in which direction it is showing the deflection. Actually it always shows in the north direction. So when you keep that compass, it will show some directions like this, from here to here. Again, when you keep here one more time like this, again here, that compass will show you in which way you have to go. So like this, every time the direction will be represented by that compass. So like this we can identify the magnetic field lines. Similarly, downward direction also, when you use that compass, it will show you from where to where we have to go. So like this, one activity is there. By using compass you can find out magnetic field lines, how they are going to be. So from where they start, from here, from the north pole of the magnet, and they comes like this and they ends at south pole of the magnet. Similarly, this side also, not only these two, we can draw many. All these magnetic field lines, they direct from north pole to south pole. Like this, magnetic field lines will be there. So this area where magnetic force can be experienced, to which area, to which extent it can be experienced, that area around the magnet will be called as magnetic field. Now very important question, that is, what are the characteristics of the magnetic field lines? Characteristics of the magnetic field lines we have to know. Let us see what are the characteristics of the magnetic field lines. One of the important question. So magnetic field lines will be drawn like this by using compass. So here just now we discussed magnetic field lines always coming out of the magnet from north pole, and they look like they are going inside the south pole. So they start from north pole and they go inside the north pole. So south pole, you can see arrow marks like this. These arrow marks are important when you draw the magnetic field lines. Sometimes they ask you to draw the magnetic field lines around the bar magnet by using a bar magnet. So what, like this you have to draw. Their arrow marks are important. Your arrow marks always should be from north pole to south pole, north direction to south direction. So this is one first important characteristic of magnetic field lines. What it is? Magnetic field lines always coming out of the north pole and they end at south pole. That is the first point. And the second point is what? Magnetic field lines are closed curves. You can see they will not be open. All these magnetic field lines will be closed curves. There will be no breakup. For example, if you see these few lines which are coming out of the pole here, they are looking like they are open, but why they are looking like that? Because we did not draw completely. If you draw them completely, again they start from north, again they end at south. Even inside the magnet also they will be there from south to north. So they are completely closed. They are not like open. They are not broken. So they are completely closed curves. Inside the magnet they will be from south to north. Outside the magnet they will be from north to south. So this is about second one. What is second uh, characteristic of magnetic field line? They are closed curves. First one is what? They starts from north and they ends at south. Third one, magnetic field lines are closer, then the magnetic field will be stronger. Where the magnetic field lines are close, their magnetic field will be strong. For example, if you see near the pole, all the magnetic field lines you can observe. All these magnetic field lines are very close. So here the strength of the magnetic field will be high. It will be so strong at the center, no, at the pole. Whereas when you are going away, magnetic field lines are far away. So their strength of the magnetic field will be less. So like this, what happens? Strength of the magnetic field depends on closeness of the magnetic field lines. Where they are very close, their field will be stronger. Where they are far away, their magnetic field will be weak. Now next one is what? Magnetic field lines never intersect each other. Only this point also many times they asked why, give the reason why magnetic field lines do not intersect each other, or justify your answer. This is one of the characteristics of the magnetic field lines, that they do not intersect each other, or they never intersect each other. Why do they never intersect each other? Because just now we have seen in the previous example, there we use compass when we draw the magnetic field lines. What happens? Compass directs from where to where magnetic field line is going. So at one single point it will not show two different north directions. What does it mean? See here, as for two lines to intersect, if you want two lines to intersect, what should happen? There must be two north directions at single point. Suppose here compass is here like this at this point, then it cannot show two different north direction, because at one single point you do not have two different north directions. So this is the reason magnetic field lines never intersect each other. That is very important point. You have to know why magnetic field lines never intersect each other. Next one, I told you already, inside the bar magnet, magnetic field lines direction will be from south to north. Outside the bar magnet, magnetic field lines will be from north to south. So these are some very important characteristics of magnetic field lines. Try to remember it. This may come for your in your exam. This is what right hand thumb rule. This is also important one. You have to know what right hand thumb rule will tell us. So here till now we discussed about only magnet. Now onwards we will discuss about magnetic field due to current. Magnetic field produced due to current. How magnetic field will be produced when current is passing through the conductor? When current is passing through the conductor, magnetic field will be produced around the conductor. For example, if you hold a magnetic field in your hand, current carrying conductor in your hand, then in your right hand, when we hold a current carrying conductor in this way, hope you can see my hand, your right hand, you have to hold a current carrying conductor in your right hand in such a way that thumb directs the current direction, thumb gives the direction of the current, whereas remaining fingers wrapped around the conductor gives the magnetic field lines direction. So here thumb will give you current direction and remaining fingers shows the magnetic field lines direction. So this is what right hand thumb rule. So this rule is important to decide in which direction current is there, or in which direction magnetic field lines are produced. They may give you question like this. They give you arrow mark, and here they ask you, for example, here one point, this side point A is given. Now at point A, magnetic field lines, whether they are going inside the plane or are they coming out of the plane, are they going inside the plane or are they going out of the plane, then how can you answer this question? Are they coming inside or outside? How do we decide? By using right hand thumb rule. Suppose current is going in the upward direction here. Then to understand this, what you have to do, you can take your pen when you are answering the question and you can hold like this, because upward direction we have to. So you can hold your hand like this, in which where you have to consider pen is only current carrying conductor. Then remaining all fingers, thumb is upwards, so current is going upwards. So remaining all fingers are wrapped around the conductor. Then here you can see, from here it is going inside and from here it is coming outside. So here what happens when you hold like this? From here it is going inside. Again from here it comes outside the plane. It is going inside the plane here and it is coming outside the plane here. Similarly, if it is arrow is showing downward direction, then what happens here? Already it is given the direction. What is happening here? Current is coming in downward direction. Current is coming in downward direction. Then magnetic field lines. How magnetic field lines are there? How they are produced? Now, like this, it is going inside here. If you take a point A here, at point A, it is going inside the plane. And if you take this side B, at B it is coming out of the plane. So by just holding that conductor and observing, by observing your thumb and remaining fingers, you can decide whether it is coming in or going out. So it is very important, right hand thumb rule is very important to decide current direction and magnetic field lines direction. You have to know what is the statement and how to apply it. Hope it is clear, everybody. Now let's see next topic what it is. Now here this is about magnetic field lines, magnetic field due to current through straight conductor. Here by seeing this figure you can understand. Here this is what a conductor which is in straight line format, and this is one cardboard. On cardboard we are going to observe how magnetic field lines are going to be produced. In this what we have, one battery ammeter to know the current and one rheostat to increase or decrease the amount of current, and one plug key. So what happens when you switch on or when you plug in, what happens? Current flow will start, the flow of current will start through the conductor, and here you can observe current is coming in downward direction. When current is coming in downward direction, we have, according to the previous rule, magnetic field lines will be produced around the conductor. By using right hand thumb rule, when current is coming down, what happens? The remaining fingers will be wrapped like this. So what direction of magnetic field lines will be? Like this. At P they are going inside and from other side they are coming out. So this diagram and about this you have to know. So here also what it can be represented by concentric circles at every point on the conductor. Hope everybody know what are concentric circles. One single center, different radii. So like this concentric circles format, magnetic field lines will be produced around the conductor, around the straight conductor when current is passed through it. And the direction of the magnetic field lines we can find out by using right hand thumb rule or compass. And here near the conductor, concentric circles will be very close. That means there the magnetic field, strength of the magnetic field will be high. When you are going away, strength of the magnetic field will be low. And the strength of the magnetic field directly proportional to the current. If more current is passed through the conductor, then strength of the magnetic field will be strong. If you are passing less current, then strength of the magnetic field will be low. So magnetic field lines or strength of the magnetic field is directly proportional to the current, and also it is inversely proportional to the distance. So when you are going away from the conductor, what happens? The magnetic field strength will be decreased. When you are coming closer to the conductor, magnetic field strength will be high. So here magnetic field, strength of the magnetic field is depending on two quantities. One is current, directly proportional to the current, and other is distance from the conductor. Distance from the conductor, if it is high, then strength of the magnet will be low. When you are going away from the conductor, strength will be decreased. So this is about what? Magnetic field produced by current through the straight conductor. Next we have circular loop. Instead of straight conductor, if you bend that wire as a loop, then what happens? At every point, the magnetic field lines will be produced in a concentric circles format like before. But here what happens when you are coming center of the circle, when you are coming center of the loop, when you are coming away from the loop, what happens? The radius of the circle will be increased point by point. When you are coming away from the loop, what is happening? The size of the circle will be increased. At the center of the loop, it looks like a straight line. That magnetic field line looks like a straight line. You can observe here, first they are like concentric circles, and slowly what is happening? The size of the circle will be increased, again increased, again increased. What happens at last? At the center, it looks like a straight line. The direction of the magnetic field inside the loop is same. Here inside the loop, magnetic field lines direction will be same, but at the center what happens? Again it follows right hand thumb rule. What factors that affect the magnetic field due to circular loop? Current carrying circular loop. Before also magnetic field was depending on current, and it is also depending on distance from the conductor. Here also same, it depends on current through the conductor, and one more, it also depends on distance from the conductor. When distance increases, magnetic field strength decreases. When distance increases, magnetic field strength decreases. And it also depends on turns here, number of turns. If there is one circular loop, there will be one kind of magnetic field strength, but when you are increasing turns, what happens? Each turn add a magnetic field strength. So what? When you are adding number of turns, magnetic field also it is going to be added, and it becomes more strong. So it is directly proportional to current, inversely proportional to distance from the conductor, and also directly proportional to the number of turns in the coil. And here one more advantage, when you reverse the direction of the current, then magnetic field poles of the magnetic field produced by the conductor also reversed. Means what? Poles also they will interchange. If you interchange negative and positive terminals, south pole and north pole also they will be interchanged here. Next topic, this is also important topic in your magnetic effects of electric current, that is about solenoid. What is solenoid? It is nothing but same like before current carrying conductor only, but it will be made as turns like a spring, a coil of many circular turns. If a coil is made into many circular turns like a spring, then what happens? It will form a cylindrical shape, and this cylindrical shape coil behaves as a magnet, bar magnet. As long as you are allowing current through these two ends, what happens? Because current is passing through the wire, in this wire, and all are there in circular turns, what happens? Magnetic field will be produced around it, and the magnetic field produced around it will be similar to the magnetic field produced by the bar magnet. Here also, like how we have north and south poles there, here also north and south poles will be there, and the magnetic field lines produced by solenoid will be similar to magnetic field produced by the bar magnet. Here also they starts from north and ends at south. They are coming out of the north pole and they are going inside the south pole. And here you can observe all the magnetic field lines inside the solenoid are parallel. Means what? Inside the solenoid, parallel magnetic field lines are there. Because of these parallel magnetic field lines, the magnetic field will be uniform, not stronger at some point and weaker at some point. Outside the bar magnet, we observed at poles, due to closeness of the magnetic fields, there it is stronger. When you are going away, it looks like it is weaker. Outside it happens, but inside what happens? All the magnetic field lines will be uniformly, means what, they are uniform. When magnetic field lines are parallel and uniform, then magnetic field strength is also uniform, not somewhere high, not somewhere low. That is also one important point you have to remember. So outside north to south, inside south to north. So what happens when you keep a soft iron rod inside this coil? What happens? Due to these magnetic field lines, that soft iron rod behaves as a magnet. As long as you keep that soft iron rod inside the coil, and when you are allowing current through it, then that rod which you are keeping inside behaves as a magnet, and we call it as temporary magnet. When you switch off the current, or when you remove that softer iron rod, what it behaves as a normal iron rod. But when you are keeping inside the coil, this turns, then what happens? It behaves as a magnet. So as per your convenience, you can use that electromagnet. Whenever you want, you can change it as a magnet, and whenever you don't want, you can make it as a normal soft iron rod. And one more advantage is what? You can increase the strength of the magnetic field, or you can decrease the strength of the magnetic field by using turns or electric current. When you increase electric current, magnetic field. So that is what advantage of temporary magnet. What is the advantage of temporary magnet? As per your requirement, you can make it as a magnet or a normal iron rod, or as per your requirement, you can increase the magnetic field strength. So these are some advantages. For a normal rod, we cannot, for a normal bar magnet, you cannot change its magnetic field strength, or you cannot change the poles. So here that advantage is there in temporary magnet. That is about temporary and permanent bar magnets. And this is one more. What happens if this current carrying conductor is placed in some external magnetic field? Means what? We learned already, whenever you are allowing current through it, whenever we allow some current through the conductor, it produces magnetic field. Now this current carrying conductor, when you are placing in other magnetic field produced by some other magnet, then what happens? What happens? That magnet also exerts some force. This also exerts some force on the current carrying conductor. This magnet will be having magnetic field, and due to that magnetic field, magnetic force will be exerted on current carrying conductor, and that magnetic force which is exerted by this magnet is equal and opposite to the magnetic force exerted by the conductor. So what? When a current carrying conductor is placed in external magnetic field, then the magnet exerts equal and opposite force on the current carrying conductor, and this displacement of the conductor is maximum. The displacement, when it is exerting some force on the conductor, what happens? The conductor will move either of the sides, either this side or that side will be exerted because of magnetic force exerted by the magnet, and that displacement will be high. The displacement will be high when the current passing through this conductor is perpendicular to the magnetic field produced by the magnet. So when current and magnetic field produced by this external magnet, if they both are perpendicular to each other, then the displacement in the conductor will be high. That one thing we have to remember. And you can change the displacement direction also, which one you want, which way you want, this side or that side, depends on the direction of current. So the displacement direction of the displacement can be changed by changing the direction of current. Here two things, it depends, the displacement direction depends on both. One is by north and south poles of the external magnet, and one more by changing the direction of the current. It also, displacement depends on direction of current, displacement depends on poles of the external magnetic field. I have seen one question that if both are changed at any time, poles of the magnet is changed and direction of the current is also changed. In that case, what happens? Because both are changed, again there will be no change in the direction of the displacement. Suppose if any one of them is changed, only current is changed, there will be change in the displacement, direction of the displacement. If only magnetic field is changed, there will be change in the direction of the displacement. When both are changed, again there will be no change in the displacement, direction of the displacement. This is about how current carrying conductor behaves when it is kept in external magnetic field. Now next topic is about Fleming's left hand rule. It gives the information about three things, that is magnetic force or force. We discussed about when current carrying conductor is placed in some external magnetic field, some force is acting on it. Because of that, it is displaced. So here three things are there: magnetic field direction is there, electric current is there, and force is there. So Fleming's left hand rule gives the information about direction of these three: force, current, and magnetic field. So here, to know the direction, what you have to do, you have to stretch your thumb, middle finger and forefinger, thumb, forefinger and middle finger of your left hand in such a way that all the three are mutually perpendicular to each other. All the three are mutually perpendicular to each other. Like this we have to keep, so that what happens, they looks like all the three are perpendicular to each other. Then what happens, here thumb directs the magnetic field, you can see here, and forefinger gives the direction of magnetic field. Thumb gives the motion, that is force. Thumb is giving the direction of force, forefinger is giving the magnetic field direction, and middle finger is current direction. So this is also one important application or rule to know in which direction what is there: magnetic field, force, and current. By using these, you can decide which is there in what direction. We can see some questions. When we see some questions, we will discuss how to apply those two. Now next one, this also some of you have confused because it is not there in your textbook, but you have seen in some question papers about alternating current and direct current. What is alternating current? Actually, here in the process of generation of current, dynamo, that is not there. In that, that is deleted. So here what happens, their direction of the current will be frequently changed. It will be reversed. Frequently the direction of current will be reversed. Means what? Alternatively the direction of current will be reversed. So such type of current will be called as alternative current. Alternate current. What is alternate current? A current which reverses its direction periodically, or alternatively if it reverses its direction, then that current will be called as alternate current. Here these also some points you have to remember about alternate current. This is what it reverses its direction at every 1/100 seconds. 1 second, in that 1/100 seconds time, at every 1/100 seconds time, this alternate current will change its direction. It reverses its direction. So we call time period, because it is a frequently it is happening, periodically it is happening. For every period, how much time it is taking. For going 100, again for coming 100, total 200. For reversing the direction, 2/100, 1/100 plus 1/100, 2/100, which is 1/50 seconds. Means after what is the time period of this? 1/50 seconds. Then what will be the frequency? Frequency is reciprocal of time period. If frequency is 1/50, time period is 1/50, then frequency will be 50, reciprocal of it, 50 hertz. So this is what frequency in India. Frequency of alternate current in India is 50 hertz. Time period in India, time period of alternate current in India is 1/50 seconds. You remember it. Then advantage. What is the advantage of alternate current? So this alternate current can be transmitted for longer distances without any loss of energy. So whatever current we are using in our home for all these appliances, electrical appliances, is nothing but alternate current, and that will be generated at a longer distance, and from there it will be transmitted to our home. So that is what alternate current. And advantage is what? It can be transmitted for longer distances without any loss of energy, because it can be easily stepped up or stepped down. We use transformers for stepping up or stepping down to make it more quantity, less quantity. So that is the advantage of alternate current. It can be transmitted to longer distances without any loss of energy. What is the disadvantage? We cannot store it in our home. Disadvantage of alternate current is what? We cannot store. You try to remember these two. Then what is direct current? In a direct current, the direction of the current cannot be reversed periodically. It will be there in a single direction, only one direction. It cannot be reversed. So that type of current will be called as direct current. We see in our home all the electronic devices, small electrical cars, all the electrical devices which are worked based on charger or battery. In our home also, when we charge a mobile phone, when it is entering into, when it is coming, it is alternate, but when it is going inside the phone, it will be converted into direct current. So that is direct current. So here, what is the advantage of direct current? Direct current can be stored. It can be stored, but what is the disadvantage? It cannot be transmitted for longer distances. It cannot be transmitted for longer distances. That is about direct current. Hope you got some idea about alternating and direct currents. Now this is our next important concept, that is about domestic electric circuit. You can see in your home also how the electric current is entering into your home. What is the schematic diagram, how it is going to be. So here what happens, like this, you can see here, it comes from pole, outside electric pole, from there it starts, from there it comes to main supply, then it will go to electrical fuse. After fuse there will be electric meter to calculate how much electrical energy is used. Then distribution box. After electric meter there will be distribution box inside the home. From there it will be sent to different electrical appliances. So before going to this, what are there in this transmission from electrical pole to our home? What all will be there? So here there are three kinds of wire. You can see in your home there will be three kinds of wires. One is called as live wire, which is in red color, red insulation color, and it is a positive. It will be connected to positive terminal. Then the next one is neutral wire, which is in black. Try to remember. Live wire will be in red color. Neutral wire is in black color. Then one more third wire is what? Earth wire. This is in green color. Earth wire will be there in green color. And in our home in India, potential difference what we use in our home is 220 volts. Okay, this is about some basic information. After that, if you observe the schematic diagram, whatever here flow chart is given, same thing it is shown in this diagram. From pole it will come like this, live wire and only neutral wire. Only live and neutral will be connected to fuse. Then it will be connected to electric meter here, which calculates electric energy. Then from there, distribution box, here we will connect some MCBs. Okay, then from here it will enter into our home. This part is what? It is a parallel connection, but till here it is a series connection. You can observe there is only one path, single path is there. So these all are in series, but once distribution box is over, all the remaining electrical appliances will be connected in parallel connection. That is the advantage of series and parallel. What happens here in parallel connection? Why we connect? Because even though one electrical appliance is damaged, remaining all will work as it is. And here series, why we connect in this fuse, why it will be connected in series? To know that, you should know the importance of fuse. That is there in the next page, but hope you got idea. And you can observe here, earth wire is not in any one of these. It is not connected here in the fuse or electrical meter, or but here when you come to, it is connected to all the electrical devices. All the electrical devices, earth wire is connected. And at last here. So what is the advantage of earth wire and why it is connected like this? We will see in the next page. Fuse and electric earth wire. So what earth wire will do? It protects us from electrical shock in case of leakage of current. If any leakage is there, suppose if anywhere that insulation damaged, then what happens? There will be some leakage of current, especially metallic body appliances like refrigerator, geyser, or some other metallic body electrical appliances. What you can feel that you are getting shocked when you touch them. When there is a leakage of current, you feel that you get shock. So that can be prevented by this earth wire. How it will be prevented? It provides a low resistance path. So what happens parallelly when you connect that earth wire, if there is some leakage of current, what happens? It passes through, because it is having earth wire is having low resistance, instead of passing through these all these, what happens? That current will passes through earth wire, and we will be saved from that electrical shock. So that is about earth wire. Next, what is called short circuit? When we call it as short circuit, these two, live wire and neutral wire, when these two come in direct contact, what happens? Accidentally, if they come in direct contact, what happens? A short circuit will happen. Due to this, what happens? Resistance of the circuit becomes low, and it may cause for overloading also. So this is about short circuiting. And then overloading. What happens in overloading? When current is drawn more than the current carrying capacity, there will be some capacity to carry the current. If it more than that, what happens? Overloading will happen. This will be due to two things. What are the two things? Accidentally hike in voltage. If voltage is 220 volts, it should be 220 volts. If it is more than that, that overloading may happen. Or if more devices are used in a single socket, we'll be having sockets. In that socket, many devices, if they are connected at a time, what happens? There may be overloading again. The current utilization will be more at single point, so that overloading may cause. So electric fuse, and these are the safety devices. What are the safety devices? Electric fuse and earth wire. Here we did not discuss about fuse, electric fuse. Electric fuse is a device which is having high resistance and low melting point. Characteristics of electric fuse is what? High resistance and low melting point. Why? Because when there is high resistance, it can produce heat, and due to that heat, what happens? At certain level, it will melt because of its low melting point. When it melts, high current when it is passing, some heat will be produced. Because of that heat produced, it will melt. When it melts, circuit will be open. When circuit is open, remaining all the devices in the home will be safe. They will not be damaged. So this is the purpose of electric fuse, connecting at the entrance before it is entering, and it will be connected in series, because there should not be some other path to enter current into the home. So electric fuse will be connected in series, and it is used to save the devices when there is some high amount of current is passing into the home. So it will prevent, it will melt, so that circuit will be broken, then it will not enter into the home, remaining all the devices will be saved. So this is about a brief explanation about magnetic effects of electric current. I am trying to do one more tomorrow or day after tomorrow on previous year questions, how they were in they may be numericals, or they may be application like right hand thumb rule, left hand rule, Fleming's left hand rule, or some other, all the different type of questions, how they have come and in what way we have to answer those questions, we will discuss. Hope it will help you. Thank you.